Hi everybody, my name is Toni Bratincevic and I'm 3D generalist specializing in environment art. Currently, I'm working for AAA game company as Digimate artist. For the first part of this tutorial, I will do a very short introduction to Redshift GPU render engine and how to set it up for final production rendering. The second part of this tutorial will be focused more on lighting in Redshift, and for that I will use one of the recent personal projects and try to redo lighting for it. Final output will be OpenEXR files for two different cameras, which we will take into Blackmagic Fusion and do a simple compositing and color corrections. Hardware that I will use are two NVIDIA GPU cards. First one is Titan RTX and 2080 Ti card. Both of them support hardware accelerated ray tracing or RTX, which we will use in Redshift render engine to speed up our scene rendering. I'm hoping that you will find some useful information in this tutorial that can possibly help you when working on your personal or professional projects. As I mentioned, Redshift is a GPU based render, and it's only GPU based. I used it for the last couple of years, and I can say that it's a production proven render, which means it's capable of rendering some very complex scenes. Compared to Unreal Engine, for example, Redshift is an offline render, which means basically that it takes a while to get to the final image quality when it's rendering. In version 3.0 there is also experimental RTX support, which means that on the cards that are 2000 series NVIDIA cards and which support RTX, there will be some speed boost, so you can turn that optics support on and off if you need it. But generally you will get maybe like 20 to 30% speed boost for most of the scenes, and there are some scenes where it's extremely beneficial, so it can be almost like 2 or 3 times faster. For example, when there is a huge grass field with a lot of instances of grass. One of the main reasons why Redshift is a production proven render is because it's built on out-of-core architecture, which means that even in the situations where GPU memory is not large enough to store all the data for rendering, so all the textures and geometry, it will still be able to render those scenes by offloading parts of the scene that are not necessary for rendering and then loading it back again on GPU when it's needed. One of the reasons also that I like to use Redshift is its ability to support a lot of these 3D Studio Max features and textures. So a lot of shaders that I used in the past for in V-Ray or Brazil or some other renders, Mental Ray for example, are still supported in Redshift. So it was very easy for me to adopt Redshift because I already knew all those textures and maps that I used in the past. So as I mentioned, out-of-core architecture is one of the main reasons why it's production proven render, and the best way to demonstrate that is to show you in 3D Studio Max how that works. Textures are usually like not a big problem for out-of-core, so even on the if you have like out-of-core texture cache set to 2 GB for example, and you have 1 TB of textures, the speed impact that Redshift has when rendering all those textures, even with that limited texture cache, will be relatively small, maybe like 5%, let's say. Geometry is a little bit more complicated, so there are situations where if you run out of geometry cache memory to store all the geometry, you can have impact up to like maybe 40 or 50% depending on the scenes. So let's go directly to Max and I can show you what out of core actually means and how to see when the Redshift is going out of core. So we are in Max now, and this is a very simple scene that I prepared to demonstrate that out of core architecture for Redshift. I'll close all these windows for now just to show you a scene that I have. So all these instances actually they are not instances, they are copies of the same object, and there are plenty of them to force Redshift to go out of core. And for every single one I apply turbo smooth modifier, which adds additional level of geometry. So if I go back to camera and let's go to render settings, and we will click on System tab and go all the way down to the bottom and click on that button Show, and that will open Redshift feedback display, which will display all the cards that you're using in your system. So in this case I have one Titan RTX which has 24 gigabytes of memory, and I have one 2080 Ti with 11 gigabytes of memory. And I will go to memory tab, and these are default settings, so I will just click render for now. Okay, so this is a frame buffer with that scene, and it will start rendering now. And if you go back to Redshift feedback display, you can see that for both of these cards there are a couple of these informations that are available in Redshift feedback display, and one of the most important ones are geometry and textures. Actually, geometry is the most important one because it can have a huge impact on render time. Not huge, but it can have impact on render times. So you can see that from that on the top, in the top row, there is 16 gigabytes of memory available, and on 2080 Ti there is 7.2 gigabytes available. And that's actually enough to store all that geometry and textures on GPU and not go out of core. So that geometry, 1.9 gigabytes, means that from those 16 gigabytes, 1.9 gigabytes Redshift used to reserve for geometry cache, and it did both of that on both of these cards, actually the same amount of that GPU memory. So it has, as I mentioned, like it has enough memory to store all the geometry data. But now I'll show you what happens when Redshift goes out of core. So that percentage of GPU memory to use, it's right now by default it's set to 90, and I'll force it I'll set it to 30, which means that memory available on both of these cards will be limited only to 30% of free memory. So if I click render again, you can see like with all the informations there is 1.9 gigabytes, and then those square brackets there is 2.3 gigabytes, and that's the amount of reserved GPU memory, and this is the amount of memory that was translated to that GPU memory for geometry. And now in this case, on the Titan RTX, there is 2.3 gigabytes of reserve memory for geometry, and 1.9 gigabytes was transferred to a GPU card, which fits into those 2.3 gigabytes. But on 2080 Ti, because it has a more limited memory space, there was only 1.4 gigabytes of reserve memory for geometry, which means that Redshift constantly uploads new geometry from the CPU memory to GPU memory when it's necessary. But even like in this situation, as I mentioned, when you're running out of GPU memory for geometry, you're still able to render scenes in Redshift. So if we compare render times, I think the second scenario where it was running out of GPU memory was maybe 30 to 40% slower for render. Over next to 10 to 15 minutes, I'll go over some important Redshift render settings. Because Redshift is relatively flexible render and it's final quality production proven render, there is a number of settings that we can tweak, but I'll just focus on a couple of them which I think are the most important ones. Okay, so I'm in Max now, and this is that simple scene that I prepared for these tests. So as you can see, if I switch to perspective, there are just a couple of these high resolution dragons. I'm using a couple of different shaders for this scene. So there is a shader that's applied to that main dragon over here, which if I switch to camera is this guy over here, and that one is using metal shader. So for that one, the reason why I use metal shader is to get a lot of reflection noise on that dragon. These dragons over here are using just a simple shader with one color and a little bit of reflection, and that's also used for the floor. And that dragon is using blue shader, just to cast some different kind of GI around the scene. For some of these other dragons, like let's say this guy and this one over here, I'm also using standard areas material shader, but I have subsurface turned on, so I can see that in subsurface multiple scattering, that one is turned on. Okay, amount is set to 1, and higher radius scale. The reason why I'm using relatively high radius scale is to get, as I said, more noise coming from these shaders, so it's more obvious what we need to tweak and how to set up render settings to get a clean render. So first thing we'll do is click on the render, and then I already did one render, but let's wait for another version. And as you can see, that camera has a small depth of field. So that can be another issue, because most of the times when you have depth of field, you need to cast more higher number of maximum samples in your unified sampler to get clean depth of field. And the first thing that I want to show you is actually NVIDIA denoiser. So let's go to render settings, and in output tab for Redshift we can go down to denoise, and that Altos, that's the other denoiser that's integrated into Redshift, which we can use for the final render, but for now we just use optics, and this one is great for interactive rendering. And if I click on interactive rendering button, then you can see how fast basically that denoiser is. So if I click on that button over here, you will see noise image with noise, and when I click off that button, then that NVIDIA denoiser kicks in and cleans up everything. So let's say I want to rotate the camera, or if I switch to perspective, and if I start rotating, you can see that it's like instant updates that you get from NVIDIA denoiser. So this thing is great for interactive rendering. I can keep it on for now, but we'll just turn it off so we can see all the noise in the image. And if I do another test render, now let's wait a couple of seconds to get the final render. Okay, I can cancel it down because I just need to focus on that middle part of the scene. I already turned on some of the AOVs, which you can find over here in that drop menu. GI, for example, shadows, subsurface scattering, reflections, diffuse filter. There are bump normals, but these other bump normals and diffuse filter are necessary for NVIDIA denoiser to work correctly. So to get all these render elements active, I just went to render elements, and then I start adding, click on add button, and then I start adding RS, for example. Let's find global illumination. So if I click on that, then that will add it basically over here. And I added RS reflection pass and subsurface pass. So these render elements are extremely useful because if I switch to beauty effects, for example, and if I turn off NVIDIA denoiser, I can see that there is noise coming from somewhere, but I'm not sure like if that's reflection or GI or something else. So if I click on those AOVs and click on GI, I can see that that noise on the floor is coming from GI. If I click on subsurface AOV, then I can see that there is also noise for AOV pass. These renders were relatively fast because these are the settings that I use for quick test renders. So if I go to Output tab and Unified Sampling, I usually use minimum number of samples set to maybe a 16 or 8 and maximum to 64, and I don't do any sampling overrides for my test renders. So if I click test render now, you can see that it only takes maybe like 20-30 seconds to get that noisy image. And in this case it is super fast, and even if I use higher render, high quality render settings for unified sampling, it will still be relatively fast because it's a simple scene, but in case I have a complex scenes, it can take a while to get to a final production quality result. So in that case, you know, these unified sampling settings needs to be relatively low to have like relatively short render time for test renders. So 864, most of the times I use that for these noise images. If I want to use a high quality final render settings, that I go to like 16 or 32. I try using minimal samples of 16 and maximum samples maybe of 256. That's my starting point. And then if I have some specific scene where there is a strong depth of field, then I can go to 1024 or maybe even higher in some cases. So for now I'll just use the 256, and for adaptive threshold I'll use 0.02, or I can try 0.01 for example. So let's quickly explain what these settings mean. So minimum samples, and if I zoom into like let's say some pixel, so minimum samples is for, let's say, that bright pixel. That's the minimum amount of samples that will be cast into that pixel. So that pixel will be sampled 16 times, and every single pixel will be sampled at minimum 16 times, which means like those samples will be distributed in that area inside the pixel, and then those samples will be averaged and as a final pixel color. For maximum samples, that's the maximum amount of samples that can be taken for one pixel, and adaptive threshold is comparing the intensity of that one pixel to surrounding pixels, and if that threshold is higher than 0.01, then Redshift will start casting more samples than these like minimum 16 samples. And maybe in some cases where there is a very high contrast in between pixels, it can reach that number of 256 samples per pixel to get to that adaptive error threshold of 0.01, which means that the contrast in between like two pixels needs to be lower than 0.01. So let's do another test render. So we will save this image and do another test render just to compare the old render settings that we use with new ones. And as you can see, this one is a little bit slower because, as I said, we are using higher render settings, higher maximum amount of samples, and adaptive threshold is set relatively low. But as you can see, there is still a lot of noise coming from multiple areas in the image. And I will try now to keep those unified sampling as they are. So we will leave them. We won't try to tweak these settings to get a better image. What we will do is go to sampling overrides, and we will start tweaking settings for the reflections and for subsurface to get a better looking and noise-free image. Okay, so if we go to old render, so this one was 26 seconds and this one takes new one takes 47 seconds, so it's almost like double render time. And you can see old render has a lot more noise compared to a new one, but there is still like a lot of noise in reflections. There is a little bit less in global illumination for subsurface scattering. Old one had a lot more noise. It's much cleaner now. So we'll go to AOVs, and let's first go to GI pass, and we can see that in that GI pass there is a lot of noise that's coming from GI. So what we can do right now is just select that small area by pressing a shift key and then dragging that crop area, and then I can go to GI and then increase number of rays. So let's say like I have 8 rays right now set that settings to 8 rays, and if I increase it to 32, it actually won't change anything. So if I render just that one section, you see that the noise is basically the same even if we increase the number of rays. And the reason why that's happening is because Redshift divides every setting for number of rays by maximum number of samples in unified sampler. So the way we need to tweak this is, even if I go to 256, which is the number that I use for maximum unified sampler, it won't change anything. So what we need to do is start increasing GI samples in increment of that number. So I need to basically multiply that number by 2 or 3 or 4 times in order to get some change. So let's go back to GI tab, and if I put 512 for example, then at that point Redshift will know that it needs to cast more GI samples for every pixel. And because we used 256 as maximum number of samples for unified sampling, we can increase that maybe to 124 to get relatively clean GI. Okay. There is still a little bit of noise, but it's not that bad when you see image zoomed out one by one, one to one. And let's render another area, and you can see over here how much cleaner it is right now. So now we will go to subsurface pass, and let's select that area over here, which has a lot of subsurface noise, and we can go to output tab and sampling overrides, and let's go to subsurface multiple scattering sample override, and we will do the same thing that we did for GI. So let's try 512 for now and render. Okay, it looks cleaner, and I think that should be probably enough. Let's try that dragon in the back, which also had a lot of subsurface noise. Okay, that looks much better. So subsurface settings are already set. Let's go to reflection settings, and we can select that dragon that has a metal shader, because metals are usually 100% reflection, which means that there you're gonna have a lot of noise coming from reflection pass. And let's turn on enable for reflection override, and I can try maybe 1024, and let's do test render. Okay, that looks much better, but there is still like some noise coming from these like very contrast areas in the back, so we can actually increase it to maybe 2048. Yeah, that looks much better. And let's render one other area to see if maybe like this one over here. Yeah, okay. So that's reflections look okay. Let's go back to beauty pass, and then we will do another test render. So click on that button and let's wait for a couple of minutes until we get the final test render. So this is a final render. As you can see, this render took 1 minute and 48 seconds to do complete image, to render complete image. And when I compare it to old render, that first one that we did with very low render settings, this one was only 26 seconds, and this is a new one. So it's relatively clean. There is a little bit of noise coming, especially like in this area over here, where it's a very high contrast area, you know, because this area is dark, and then there is a reflection on the corner of that dragon. This area is relatively clean, and there is a little bit of noise coming from GI pass, so we can tweak that by increasing more like the GI samples, and for that foreground area we can increase the reflection samples. In this case over here, where there is a lot of noise coming from the reflection, and that's only because we are using depth of field. What I can do is increase the maximum number of samples for unified sampler, but then also proportional to that increase, I need to increase reflection samples to compensate for that maximum amount of samples. Because if I put over here 1024, it is possible that sometimes I will get worse result by increasing those samples, because I was doing specific override for reflection samples. So in this case I need to go higher with these settings in order to compensate for those, as I said, for those maximum samples. For now I'll just keep it to 56. And if I switch back to beauty pass, and if I turn on, so this is without denoiser, and especially like in this area you can see like how denoiser does a relatively good job. This is NVIDIA denoiser, so it is possible that sometimes you can use it for final renders, but the thing is that there are cases where it kind of like destroys the sharp corners and they look very blurry. So in this situation it's actually working relatively good. I don't see any problems with NVIDIA denoiser for this scene. Okay, so some of the other things that I think are useful for when I'm doing like interactive rendering, and these very fast final render scene frame buffer. So let's go over some of these options on the top. This is automatic freeze tessellation, which means that if I have a displacement on some of these objects, if I try to move the camera around, like let's say if I'm doing IPR and then I start moving camera, displacement will only be calculated for one frame, not for every single move that when I start moving the camera. So it will only be calculated when I click on that button, and then it will freeze that tessellation, and then as I move the camera it will just reuse that tessellation for displacement. Over here we already saw how we can switch between different AOV passes. First button is for final render, the second button is for IPR, third button is to refresh IPR. So sometimes maybe if I add like a new object in the scene, maybe it doesn't automatically refresh IPR, so I can click on that button to see that object in IPR. These are all for like taking a snapshot, so I can save that as a history for frame buffer. You can also lock the camera, so if I switch to a specific camera over here, let's say camera 1, I can click on that button to lock the camera, so when I start moving in viewport it doesn't switch to perspective automatically. It just keeps that camera locked for IPR. If I press that button on the top right side, I can get a number of settings that I can use to tweak color correction directly in viewport. So this is without, so it's already, there is already some color corrections that I set for this scene. So that's the render without any color corrections. This is just a raw render. And then what I did basically is if I enable post effects and I use a specific lookup table, so if I turn it off, on, and I can switch between different lookup tables. These are useful just to get some impression what you can do later in compositing in Fusion, because for the final renderer I wouldn't use these settings over here and these specific lookup tables. I'll just try, if I find something that's relatively useful and it has nice color correction, let's say this one over here, I'll try to replicate exactly the same thing in Fusion later, just to have a little bit more control over the final color correction. So if I open color controls, I can tweak exposure over here, I can increase or decrease the contrast. If I go to photographic exposure, one very useful thing that I usually do is if I set this one to 1, you can see that some areas are clipping because it's more than 100% white. So if I turn that one on and if I start reducing that one, it will compress those highlights, so they are back from in range of 0 to 1. We can go all the way down, which will basically compress it all the way, so all the values are basically under 1. But it's certainly, you know, sometimes I leave it like maybe 0.4 or 0.3, so there is still like a little bit of clipping, but it's not as obvious as having it set to 1. There are also a number of different settings over here, which you can find the explanation in help, like exposure based on ISO or shutter ratio. You can tweak a white point, some vignetting. Bloom is relatively interesting because you can do some of, you know, based on the, let's increase the threshold to, it can go higher. If I decrease intensity, so you can see some bloom happening in the scene, so you can add some like flares or streaks, which is useful just to do like these quick previews. So you can always turn this one on and tweak colors a little bit just to experiment like what you can do later in compositing, and that's the only reason why I use those color corrections in a frame buffer. So for, I don't know if I mentioned, but for optics there is still like it's still like experimental options for RT support, and you can find it over here. So just make sure that this one is turned on, because in most of the cases that will produce a faster render time. And I think that's basically it for this chapter. We went over some like very basic settings, which these are the most important ones, and which we will use later in to do. We'll basically be tweaking the same settings to get a final production for some of the latest chapters when I show you how to do production lighting for one of the scenes that I prepared. Now we can quickly go over some of the Redshift lights. So for that we will go over dome lights, HDR lighting, and then we will play a little bit with physical light. And there are a couple of types of physical lights that we can use in Redshift. So we will switch between rectangle, we will look into disk light, spotlight, and some other types. We will also try to play with fog a little bit and see how we can control fog per light. At the end I'll also add depth of field, and I'll show you how to set it up for the scene. And then Last thing that we will look into is light groups and how to name light groups and how to separate it in a couple of different light groups, which we can use later for compositing. So this is that extremely simple Mac scenes that I will use to show you all these light types. It should be relatively simple, just so in interactivity is fast, so I can run IPR and you can see like instant updates in frame buffer. So let's just get rid of this light and go to Create tab, Lights, go to Redshift tab, and for now we're just going to create a physical light, and by default it's set to rectangle, and then we'll just move it up. So that's area light. It's using rectangle as a shape. It's set to rectangle by default, so you can see over here light type, it's set to area, and then in area section over here I'll set it to visible so it's easier to see it in IPR. We can switch between different shapes, so most of the time I just use rectangle, but you know, there is also like a disk which should be scaled to 100%. So there is a disk light, and then there is a different like sphere shape, and then you can switch to cylinder. So let's just so you can scale it in the viewport, but there is also length over here which I can use to control the length of that cylinder shape, and then thickness. Visible makes it invisible to primary rays when rendering, so it's still casting that light into the scene, but it's not visible to camera. When I turn it on, it's obviously visible to camera. There's that last shape type, which is mesh. So let's quickly do maybe torus, and I'll put it over here. And if I go back to light settings, if I switch to mesh, then I can pick mesh from the scene, and I can use that mesh for lighting. Just put it over here. There you go. So you can pick any type of mesh, or maybe I can even like edit that torus. Let's see if that's gonna work. Yeah, it works okay. So you can modify original shape, which I can just move over here so it's not visible, and then when you modify it, it will also modify the light shape. But for now, I'll just put it back to rectangle light, and let's put it over here somewhere. So intensity, so color of the light first. If you switch modes to color, then if I click on that box, I can pick a different color, so I can turn it into like red light. If I want to use temperature, then I can switch to temperature. So candlelight would be like maybe around like 3000 kelvins. Maybe if I want to do some artificial lighting, then it will be a higher number, like 12,000. Intensity, like straightforward, higher numbers, stronger light, smaller numbers, it will be darker. That light is using square fall off, so as I move it up, it will be darker, obviously, and as it's closer to subject or some meshes in the scene, and it will cast more light. There is also one settings that I usually use to do a little bit more specific directional lighting, which is in area lights section. There is a spread option. So if I set that 0, it will cast from that rectangle, it will cast parallel light directly on the ground. And if you do set spread to 1, then it will cast that light in all directions. So basically like 180 degrees from 90 degrees actually from that light normal, like that arrow that you see over here. So if we set it to 0.5, then it will be more like some type of spotlight. There are also different type of lights. So this one is area light, which is default light in Redshift. I can also switch to point light, which is similar to basically area sphere light, but this one I think is fakes spectral reflections because it's infinitely small light. Spotlight is the one that I use a lot because I can control the direction and the fall off of the spotlight. It's a little bit easier to control it compared to area light. Let's bump up intensity to maybe 5000 so you can see it better. Let's put it over here. So for spotlight, there is a specific section to control the angle of the spotlight. So cone angle will make it more, you will decrease the radius, and then we can also increase that radius. Fall off angle is that central circle, the radius of that central circle, and from that's gonna be the most intense part of the spotlight, and then from that edge to this outer corner you can control fall off by increasing or decreasing fall off curve. So like 1 is default. If you want to be more concentrated in that central area, then you can set a higher fall off. Directional light, I use it for sunlight. So directional light by default doesn't have any square fall off, inverse square fall off, like other types of light. So that intensity should be like lower, because if you set it to like 5000, then it's just too strong, and then you need to compensate that by doing some sort of a tone mapping. So in this situation, I'll just set it to like lower value. Usually I use it from like 0 to 1. But depending on the scene, like maybe, as I said, if let's go to exposure controls, not photographic exposure, but this one. And then, if you have different type of exposure, then in that case, maybe I'll use higher intensity for the directional light. So let's go back to area light, and I'll reset that rotation. So it's 0. And just move it 90 degrees, and then increase the intensity, let's say, to 200. So to add fog to that scene, I can go to rendering, go to environment. In atmosphere tab, I'll click add and add Redshift volume scattering. When I add it to the scene and when I refresh that IPR, nothing happens, and that's because by default all the lights that you create in Redshift are set to use 0 for fog contribution. So if I want that light to cast some fog into the scene, I'll go to volume tab and I'll increase that contribution, let's say to 0.1, and then you're gonna see that fog. Those values are generally should be relatively low, so in some cases maybe it will be like 0.02, and even in environment tab, if you go to Redshift volume scattering, even that scattering is always relatively low, because if it's set to 1, and let's set this one to 1, it's extremely bright and it does wash out everything. So let's set it to lower value. So let's go back to directionality, actually spread, in that area section. So over here you can see if I set it to 1, then that fog is visible everywhere. If I set it to lower value, then you'll get that kind of effect where fog and light are more directional. Fog intensity can be controlled per light, so let's copy that light a couple of times. Let's just use this one, and I'll use even lower spread, and then I'll make 4 copies of that light. So because it's a copy of that original light, every single light has the same contribution to fog. But I can pick one and then I can go to volume tab, which is over here, and then I can set it maybe to 0, and then that area light will not cast any, will not interact with the volume in the scene. So 0.005 for this one, and then this one can be higher, maybe 0.1, so this one is brighter. It's still, that area light is, all these like 4 area lights actually use the same intensity. The only difference is that this last light is contributing more to fog that's in the scene. So for depth of field, let's come closer to that sphere. And I'll go back to these area lights, and let's also delete this last one, and then we'll just go to that one, reposition it, maybe make it a little bit bigger, and let's go to spread, and we'll make that spread maybe like 0.6 or something like that. Okay. At this point I don't think we need that volume, but I'll leave it to like some very low value, maybe 0.002. Okay, and so let's go down to that sphere, and you know what, like let's go back to that light and kill volume completely, so 0. So back to that sphere, and I'll use copy just to have something in the back. And I'll quickly go to material editor just to make that sphere brighter, because right now it doesn't have any diffuse. So let's see, that's this shader over here, metal, and then maybe put this on to 0.3, and that, okay, there you go. So to add depth of field, I'll just go to rendering, environment tab, and then we don't need that volume scattering, so we'll kill that one. In effects tab, we will click add, and then add redshift bokeh. For now, I'll leave it as it is. We'll go back to create, and then I'll make a camera, and I'll create free camera, put it over here, and then align it to view. And now I switch to camera, which you can see over here, and it will switch this onto camera over here. So I'll select that camera, select camera, go to modifier tab, and then we will set the target distance. So to set that target distance, what I usually do is I just use clipping to find the distance. So let's just move that clip plane to 144. So that's the setting. And then I'll turn off clipping, and I'll paste that into target distance. Now that target distance is set to this sphere basically. And then let's go back to environment tab, redshift bokeh, and you see that derive focus distance from the camera. That means that it is using that focus distance that's set on the camera. And then COC radius, if I increase it, then it will give me stronger depth of field. If I decrease it, it will be more sharper. So if I set it to 10, it will be extremely blurry. You can use custom bokeh image. So if you click on that one, you can, choose like different type of image for bokeh. which I'm not going to use at this point. I usually use just like a regular depth of field. Aspect, I don't use that one, and power, this like default settings are more than enough for majority of images that I'm rendering. So the last thing that I want to show you, and we will use the same scene, is light groups. For that, I'll just take that light and I'll turn it into, we can actually leave it, this one we can leave as area light, and then I'll copy that light and I'll switch that light to spherical light. So let's see, shape, I'll switch that to sphere, and then I'll decrease intensity maybe to 5, and then I'll move it somewhere over here and reduce that radius. And let's put it over here somewhere. I'll switch to color, and maybe I'll use some different color. Something a little bit more orange. So it looks like intensity is very low. I can say to like 200, maybe like a little bit higher, 400. Okay, so we'll put that light over here, and we'll put another one on this side, and this one will put it as, change the color to something more blue. For that top area light, I'll just decrease the intensity maybe to 20, and I'll make another copy and I'll put it over here, almost parallel to that first one. So for this one over here, I'll make another copy, and let's put it over there, and let's make another copy for this blue one, and that's it basically. So what I'll do right now is I'll create light groups. So I'll go to that first area light, and you can see that section light groups. We'll just put it top area. I'll copy that name, so top area, copy. We'll go to that second area light, put it over there. For this sphere, we'll call it small orange, and we'll paste that same light group over here. For that blue spherical light, we'll call it blue, and let's go to that. So let's put the same name, blue, blue. So we basically did set up all the light groups. So by default, you won't be able to see those light groups over here. So what I need to do is go to render settings, and I'll go to render elements. All these render elements I don't need at this point, so I'll just delete them. Okay, and then I'll click add, and then we'll just add RS beauty. And for light groups over here in this section, we'll just say all light groups, and we can put that on reminder. So if I do another test render right now, if I do interactive render, you're gonna see that in that AOE section over here, we have separate light groups for those blue lights. We have separate light group for the small orange lights, and separate light group for the top lights. Other means if let's say that one of these spheres that I have in the scene is I'll quickly create a Redshift incandescent material, and then I'll assign it to that sphere and increase that intensity multiply maybe to 500. So that's a self-illuminated material on that sphere, and when I go to different AOVs for light groups, so if I go to blue for example, then that light material won't be included in the beauty blue light group, and it won't be included over here or over here. So everything that's self-illuminated is basically beauty other when you exclude all the lights. Even if let's say if I go to Redshift and if I put another physical light, not this one, okay, let's just put that physical light over here, and if I re-render, then I think that physical light, if it doesn't have any light groups, it should be included in beauty other. So it is included in that light group because in render settings, when I go to render elements in beauty paths in light group section, I put it to reminder, and if I put it to all, and if I re-render again, then only light groups that are set that have a name for the light group will be rendered as a separate light group, but everything together will be included as a beauty path. So that reminder of everything that's not in part of the light groups, you won't be able to see it over here, which is something that you want to have for compositing later. So I usually go to render elements, and by default I set it to reminder. So there is another render element that's called beauty other, which includes all these elements that don't have its own light group. So if I do want to switch that light to a specific light group, and let's go back to blue, for example, or maybe like this top area light, I can just copy that light group name. I can go to that spherical light, and when let's just switch to top area, and you see, like, if I delete that light group, then it won't be included in that light group that's shared between these two top area lights. But if I paste that name, then you will automatically see it in interactive render over here. So these light groups are great because you can render separate AOVs for different light groups, and then in Photoshop or in some compositing app like Fusion or Nuke, you can put like these elements together, and you'll basically get a beauty path, but you still have ability to control the intensity and the color for every light group that you render.